Hey everyone, it is Mr. Vargas here once again, looking to help out my Math 8 students, this time with homework 4.2, Relations, coming from page 281 in the course textbook. Before we get started, some really quick things that we're learning about in class. When we're dealing with functions, we have three different ways that we can represent them. The first way is through a table, and tables just look like that. These are my favorite. You got your x and your y coordinates. The next ones that we can do is through equations or algebra. So that's like, y equals mx plus b. That's just a linear function or a linear equation. These words are kind of synonymous. They kind of mean the same thing for now. And then the last way that we can do that is graphically. So when you draw out a function on a graph, you've got your xy coordinate plane, and then you get some type of function. Maybe it's a straight line, and it just looks like this. So those are the three different ways that we can represent functions. Alright, so let's check out problem number 1. So for problem number 1, so we've got these coordinate pairs. I've drawn them out right here for you. We've got 8, 5, negative 6, negative 9, 2, 5, 0, negative 8. Alright, so we are asked to express these as the domain, the range, fill out the table, and then graph the points. We can do all of those pretty quickly. Now if I go back up to these points, all I have is one point here, another point here, third point here, and a fourth point here. And let's just go ahead and label these. This is my x, this is my y, this is my x, this is my y, and you kind of get the point. Get the point. Okay. Bad joke. So let's go ahead and fill out our table. So when my x was 8, I've got 8, negative 6, 2, and 0 for all of my x's. When my x was 8, my y is 5. When my x is negative 6, my y is negative 9. When my x is 2, my y is 5. And then when my x is 0, my y is negative 8. Awesome. Now the new words, new vocabulary, is domain and range. And really, it's not too difficult. You already know these things. You're just having a new word to describe what's going on in your relation. Your domain is just all of your blue values, or your x's. So the domain is always your x values. So let's just go ahead and write that after the word domain. You can write this on your homework sheet, and then you're going to write all of the x values in one set, or in one list. Typically you want to do this in order from least to greatest. So my smallest number is negative 6, so I'm going to put that one first. That's my smallest x. My next biggest x is 0, then 2, then 8. So those are all of the numbers that are in what is called my domain. Now all of the numbers in my range are just my y values, all the red numbers here. So let's go ahead and write those numbers in order from least to greatest. Negative 9 is the smallest, negative 8 comes after that, and then we've got 2 5s. We don't need to write it twice. So there we go, we have our domain and our range. The last step is to just go ahead and graph those points. You can use either the table or just your coordinates like usual. So I'll start out with 8, 5. Start in the middle, go right 8 spaces, 1, 2, 3, 4, 5, 6, 7, 8, up 5, 1, 2, 3, 4, 5. So your point should be right about there. Okay, next point is negative 6, negative 9. Go to the left 6, 1, 2, 3, 4, 5, 6, then go down 9. 2, 3, 4, 5, 6, 7, 8, 9. So something like this. Way down there is your next point. And then you've got 2, 5, which is just right there. Right 2, up 5. And then the last point is 0, -8. So I don't go left and right, and I just go down 8. And it would be right there. Okay. Teddy thinks we have some visitors today, but we actually don't. Poor Teddy. Alright, let's go on to number 3. Number 2 is exactly like number 1, just with some fractions. But same deal for domain and range. Okay, number 3 says we've got 825 cars per day, and they ask you to create a table of values for 1 day, 2 days, 3 days, 4 days, and 5 days. So I pretty much did this for you already. I've got days for D, and I want to know how many cars I have on 1 day, 2 days, 3 days, 4 days, and 5 days. I know that 1 day produces 825 cars, so now the question just becomes, what happens from here to here? What happens on 2 days? Well, all I gotta do is 825. Since 825 cars are produced per day, I know that if I go to the second day, all I have to do is multiply that number by 2, and that will get me my next number in the list. And you should get 1650. So after 2 days, I've got 1650 cars. What happens on the third day? Yeah, you guessed it. You're just going to do 825 times 3. Or you could also do 825 plus 1650. I'm just going to do multiplication since it's faster. And you get 2475. Alright. And if you keep doing this process, the next number would just be 3300. And once again, add 825 to that, and you'd get 4125. And if you don't understand how I got that, all you can do is just multiply your days by 825. So if I need to figure out 5 days, I just do 5 times 825, and that will get me 4125. Alright, number 4 then says to graph those points, graph those ordered pairs. So let me write those ordered pairs here. I've got, as you can see, I created my XY plane, or my DC plane in this case, where days go up and down, cars go left and right. So the ordered pairs that I need to graph are 1, 825, 2, 1650, 3, what was it, 2475. Then I need to graph 4, 3300, and then 5, 4125. Those are all the points that I need to graph. I made my Y, or my D, my vertical axis, just by days, 1, 2, 3, 4, 5. And then for my horizontal axis, I just used thousands. 1,000, 2,000, 3,000, 4,000, 5,000. Since the cars are going to be in the thousands the more we go up. Alright, so 1, 825 would be right about here. Not quite to 1,000. Definitely at 1 though. And then for 2, it would be 1650. So it's probably going to be a little bit further than the middle of this. Okay, so that's about good. And we're just kind of estimating. For 3, it's about halfway between 2,000 and 3,000. 2475 is pretty close to 2,500. So I'm going to put that right in the middle. Right there. For 4, 3,300, so just slightly above 3,000. So this looks like a pretty good estimate. And then for 5, it's 4,125. So just above 4,000. And we can see we created a nice linear pattern here. Alright, let's take a quick peep at number 5. So number 5, we've got this table of values. Our x's on the left, our y's on the right, and our pairs go from 1 to 1, 2 to 4, 3 to 9, 4 to 16, 5 to 25. What's the pattern here? Well, how do I make a 1 become a 1? Then how do I make a 2 become a 4, a 3 become a 9? And I have to keep that same pattern the whole way down. This one is actually the squared pattern. So you could write this as an equation. X squared equals y. And what do I mean? Check it out. If I replace my x, my 1 here with x here, and my 1 here with y here, well, what's 1 squared? 1 times 1 is 1. Okay, how about 2 squared? 2 squared is 2 times 2, which makes 4. 3 squared, so if my x is 3, 3 squared is 3 times 3, which makes 9. 4 squared is 4 times 4, which makes 16. So this is called the squared pattern. I'll leave the rest up to you guys. And so make sure you graph these points on the XY coordinate plane they provide you with, and see if you can figure out what type of graph this is. It's going to look a little bit different than the ones that we've graphed in class before. Alright, so that's it for this video. See you next time.